uh, slide or the
The slides showing that it in the presenting form.
okay.
Okay, but there is a black bar on the right side. I don't know what it
Oh,
is.
okay. Okay. Let me remove
Okay.
it.
Oh yeah, now it's gone.
Okay.
Yep.
So, good morning, everyone. I'm gonna be reporting about the ELECTRE, also known as the elimination and choice of expressing reality.
Oh.
So, I would try to apply the application of ELECTRE in the situation of sourcing subcontractors. Okay. So here would be the summary of all the topics that we would discuss in this ELECTRE. So first, we would want to determine what is ELECTRE. Then, what would be the main difference of this process to other MCDM process that we have discussed, which is the HP and the goal programming. Also, what are the different kinds of ELECTRE? Because ELECTRE is actually a big family that consists of different processes used in different decision methods. Okay. Then the application of ELECTRE using Excel. Okay. So what is ELECTRE? So ELECTRE is actually introduced by Bernard Roy, or also known as the father of ELECTRE. And actually, there are actually three authors in this decision method, which is R. Beneon and B. Sussman. I don't know what's their name because in their paper they just put their initials. So basically, there are actually three, but the most recognized among them is Bernard Roy, since he was able to come up with this idea on how you would outrank using ELECTRE. So ELECTRE actually utilizes also pairwise comparison, and it used to eliminate the weak alternatives uh, among all of the decisions that are being made in a specific situation. So the specific advantage of this process is that it avoids the compensation between criteria and the normalization process. So what does that mean? So uh, similar to unlike to AHP, AHP uses the priority of criterias. In Electre, we do not use priority when it comes to dealing with criterias, but we use weights. And commonly, when we are using AHP, when we try to change the priority of each criteria, the the alternatives that are being chosen changes. So, for instance, if we have three criterias and two two alternatives, when we try to prioritize, let's say, criteria two, then the outcome would result that alternative one would be the strongest alternative when it comes to prioritizing criteria two. But when you change the priority to criteria three being the top priority, it changes to it changes to alternative the other alternative. So meaning once you change the priority, the alternative varies depending on what priority on what you are prioritizing based on criteria. in in a sense, Electra does not use prioritization that way, meaning as we try to eliminate the weak alternatives, they're already eliminated on the choices to the decision maker. Okay, whether whether the weights of the criteria 1 is much greater than criteria 2, or vice versa, it would still remain the same. It would once the alternative is weak, then it's completely eliminated. Okay, so this technique would be advantageous, especially when you have a lot of alternatives. So in terms of subcontracting, actually, for instance, when you are dealing with construction, you have a lot of contractors when it comes to dealing a structure of a building. You do not only have one contractor in constructing a building. So having the Electre would help you pick who would be the most advantageous alternative among them. Okay? So here is what we learned so far, and we would try to compare these three between them. Okay, so goal programming, as we discussed in the first week, it is the a linear programming uh, technique that uses also a goal constraint, meaning you have a certain goals that you want to be achieved at a certain condition. Okay, so our goal here is that we need to provide a satisfying solution. What does that mean? So it would mean that you are completely not satisfying completely, but you are also not sufficing completely. So you are just giving what you have achieved in the meantime in calculating the optimal solution for the problem. So as a result, it gives you the deviation of each goal to being achieved. Okay. So as we discussed also, the AHP, they use pairwise comparison, hierarchical decomposition, and identify the alternatives performance based on a given priority of the or for each criteria. Now, for Electre, we try to identify what would be the weakest alternative and what would be the strongest alternative relative to the criteria being given. So commonly used when there is a lot of alternatives. Is it clear so far?
Uh, yep. So
Yes.
yes, I
Is it
think
too fast?
not really. Do you
Okay.
want us to discuss in the middle or like at the end of your presentation?
I you yes, you can ask right away if you have any questions about
Okay,
the lecture.
okay.
Okay.
Great to know about that, William. I
Okay.
think you can continue first.
Thank you.
Okay. So, what are the different electric processes, or as we say, the electric family? Okay, so there are one, two, three, four, five, six, seven, eight, eight actually, eight main families when it comes to electre. So, electre one is the origin of all electre. So that is the one that has been created or been introduced by Bernard Roy. Okay. So basically, it is an outranking method without any concepts being applied. Now, they have seen a quite a flaw when it comes to dealing with the Electre one. So they introduced Electre one veto concept. So what does veto concept mean? If you would know veto both, if you contribute to a uh, certain situation, your contribution gives you the amount of vote based on your amount of contribution given to the basic situation. So for instance, in a company, if you have the 40% shares in that company, then you have you have a much higher vote than other shareholders that have much lesser than 40%. Okay. So that is what they want to apply here, the veto concept. Do you understand that, the veto concept?
Yep, yep.
Okay.
So we can like directly eliminate it either
Yes.
one of two criteria
Yes.
based on the decision maker. Yep.
Okay. So now,
Anyway, if Red or others like K have question, please feel free.
Okay. Thank you.
Okay, continue, William.
okay, so now they have also improved the veto concept because it's also quite a flaw for them. So they applied Electre IS, which applies the pseudo criteria. So basically, they are applying dummy codes in the dummy criteria, sorry, dummy criterias in the electric process, so that they could perform iterations when it comes to dealing with outranking. So now when it comes to ELECTRE 2. So it is the origin of a ranking problem. So this at this time we are now on the part that we use ELECTRE in a ranking problem. So this is actually that we would discuss the ELECTRE 3, since we would apply pseudo criteria plus outranking degrees. At first, the first three we try to apply a choice problem. So as they enter to ELECTRE IS, this is now the verge of ELECTRE being used as a ranking problem. Okay. Now, similar to this, they have applied the flaws when it comes to the ranking problem, and the verge that put them in a sorting that uses ELECTRE in a sorting problem would be the ELECTRE 4, because they would try to neglect the power of the criteria's importance. Because as we know, if we try to apply the criteria based on the prioritization of criteria, we are much um, doing an AHP concept. Okay, so in ELECTRE, they try to prove that you do not need actually to have the importance to prioritize the importance of the criterias. Then now that it is moved to a sorting problem, it is now being used as a supervised classification based on boundaries and supervised classification based on centroids. So actually, this is a much complex ELECTRE. So, but we would not discuss this because it's actually performed in a software.
So 3B, 3C
Yeah,
is not really on the MCDM domain knowledge, right?
yeah, yeah,
Okay, more to like data science stuff.
yes.
Okay, very good, very good.
Okay. Now, the common vocabulary that you would hear in ELECTRE, uh, 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 just a minute. So, we would discuss about ELECTRE 3, which is the composition of the pseudo criteria concept and the outranking degree. So, this is what we would perform later on in Excel. Okay. So, So here are the common vocabularies used in ELECTRE. So concordance, this is the measurement of an alternative meeting satisfaction based on the criteria, thus showing that an alternative outranks other alternative relative to its criteria. So meaning concordance in an easy form is actually the strongest alternative out based on all alternatives that are being given. Now discordance is actually the opposite of that. So it would mean easily that it is the weakest alternative among those alternatives given. Now, commonly we would see matrices or matrix. So it is a set of numbers represented in rows and columns. And then the numbers represent a coefficient of a certain intersection of two events that occurs at the same time. Okay. Now, other vocabularies: superiority or superior, inferior, and outrank. So basically, as it is, you would know the meaning of that by now. Okay. So applying ELECTRE in selecting subcontractors. Now, this is what I've created. So I have actually went to a visit in a customized jersey uniforms manufacturer. And what I have known for them is that once they have achieved a certain amount of units, and they have a lot of orders that they cannot be capacitated through their manufacturing line, they try to find subcontractors that would do the remaining units that they would need to achieve by the end of a month. So they have at least 10 subcontractors along the area that would service them to provide the remaining units. Okay. So I try to create a problem, to simulate a problem in that sense, so that we would know how we could possibly use ELECTRE in real world applications. Okay. So a customized jersey uniforms manufacturer was able to get a monthly orders of an average of 100,000 units per month. However, due to capacity constraints, we're only able to produce a less of that in a month. So actually they do not disclose that, so I put it vaguely. So thus they would need a subcontractor that would fill the remaining orders, and and however they would need to pick the right subcontractors for the job that would match up their way of production, because when you are looking for subcontractors in a manufacturing line, you want to find the best subcontractors that actually has the same qualities in your production line. So you do not want someone who would produce much less of a quality to give to your customers, because that would represent your reputation as a company. Meaning, if you provided a much lower quality than your in-house products, then uh, you would possibly lose customers in the long run. So the company was able to establish a criteria and their weights that would set a standard for all contractors that would bid for the orders. So one is the criteria one would be the number of jersey and sando produced per day. Okay. Then uh number two would be the number of jersey shorts. So a jersey, when you have top a a top and a short. Okay, so they would want to know how much can they produce in per day, so that they would know how many contractors they would get in the long run. Now,
Uh, 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 William.
yes.
So C1 and C2, doesn't it like in line with each other? Because when they produce the what is C1 in a
C,
whole
uh
in or what?
C1, excuse me.
Uh-huh.
C1,
C1 is the top and the short.
no, C1 is the top one, the top
Oh,
jersey.
okay.
The one you wear
Okay.
in the top.
They
When
have two like
yes,
two
because
machine or
uh
okay, two
it's
capacity. Yeah.
yeah, it's actually quite different in terms of
Okay.
manufacturing, because in on your top you write the name of the team,
Mm-hmm.
the name of the player on the back, and then their numbers.
Oh yeah, yeah.
Okay, so
It's
you
it's
have
more
a different
difficult.
process.
Yeah.
Yes.
Okay. Oh yeah, Red is raising hand. Yeah.
I
Go
just
ahead.
wanted to ask, so they're not supposed to, they're not really required to produce a pair. So it depends. The number of jersey sando will be different from the number of shorts produced.
Yes, because it would in a manufacturing line they would have a different time of production. Okay, so possibly
I
that
Yeah, I understand.
as
I just wanted to
as
clear, William.
uh
So in the statement of the problem, monthly orders. So the orders are separate completely. It doesn't mean that
no
they are ordered
uh,
in pair.
no, they are ordered in pair. They are
Uh,
ordered in pair.
okay.
So that 100,000 units is ordered as a pair. So you have the
As a
shorts and the
pair.
sando.
Okay.
So here in C1 and C2 we have a different time in
Mm,
production when it comes
mm,
to the two attires. So
Okay. I get it. Yeah.
so for instance, if we have 1,350 sandos, then if we have produced shorts that are 1,850, we would only have 1,350 pairs.
Pairs. Okay.
Okay.
Thank you. Yeah.
Okay. So the KPI scored, it's actually quite important for them, but they have a specific measure that they do not disclose for me. Then the efficiency score of the subcontractors and the quality comparison. So they try to send um, samples of the outputs of the subcontractors. Then they try to rate it, compare, benchmark all of the qualities of the product and relative to its pricing. Now, they also try to include the criteria of the waste reduced in production. So uh, the company tries to promote sustainable manufacturing. Okay. So they try to eliminate also the subcontractors. They try to consider the subcontractors' waste when it comes to producing one jersey uniform. So they try to include it into account as well. So now I actually used the numbers the numbers used in a particular example and try to mirror it in this problem. So there are actually four subcontractors that were able to submit their proposals and the measures the company are looking for as shown in the table. Okay, here. So these are their criteria: the 2.2336, 0.1652, 0.3355, and so on.
Mhm.
Okay. So we would try to apply this in Excel. So let me just change my share screen and uh, transfer it to Excel. Okay. Can you now see the Excel?
Yep.
Okay.
Yes.
So as you can see, I did not include in the PowerPoint the steps in uh, creating the Electre in Excel because I
Mhm.
want it to be uh, flawless when it comes to
Mm.
discussing the Excel and not actually changing the share screen to Excel and PowerPoint. So I just combined them in Excel. Okay.
Okay.
So please bear with me. So at first, we would need to create the matrices or the matrix, sorry, for this situation, the subcontractors. So we would follow the same table that we have done in the slide. So I just copied it here. Okay. So that's their values, and this would represent an element. So 1350 represents element of subcontractor 1 based on criteria 1, and so on. Okay. So A would represent the element small a. So now we would try to calculate the normalizing matrix or the normalized decision matrix. So how can we calculate that? We would use this formula. Okay. So in essence, this is the element xij would be calculated, or the normalized element would be calculated by the element created in the matrix, which is this one. This is aij. This would represent aij. Then over the summation, or over the square root of the summation of um, the squared aij. Okay. So we would just square these values, which would in turn uh, result into this. So we try to square this one, and that's what you would get in this process, in this a squared k element row k and column j. Okay. So apply it for all of the elements, or this one. Apply it for all the elements so that we could get this one. And then we try to sum. Okay. We try to sum this so that we could get the values. Okay. So we just apply sum for this column. Okay. So here is the formula. Okay. So for all columns. Then we get the square root for all columns as well. Do you want me to manually, or is it okay? Do you understand it so far?
Yeah, so far, yeah, up
Yeah.
to this
Yeah.
point.
Okay.
Mhm. This is still easy, the
Okay.
calculation. Yeah.
Okay.
Okay.
Because some people does not know how actually to read this one.
Yeah.
So I really try to explain it in a simple manner. Okay. So now that we have obtained this one,
Mhm.
uh we would try we would now divide we have now obtained this one, the encircled in red, this square root. We would now divide it to the element that we have created. So we divide this one over this one. Okay. This one, sorry. This one. The square root. Okay. And we apply it for all of the elements relative to their column. Okay. So this one would be element subcontractor 1 to criteria 2 divided by the square root of the column 2. Okay. Now that we have created the normalized matrix, we would now get the weighted matrix, or we would calculate the weighted normalized matrix. So we would just actually multiply this one, multiply the weights for each criteria on the obtained normalized matrix. Okay, so there you go. We would just multiply them. Now, keep in mind that this weights should be equal to 1 as represented by this equation. So this should always be equal to 1.
William, I think
Yes.
I missed some part
Okay.
where you explain that how do you get with the weighted weight of each criteria earlier?
Oh, okay. So
Mm-hmm.
it's actually in the problem.
Mm-hmm.
I have already established the weights because
Mm-hmm.
okay, so we could actually get the weights based on the decision makers preference. So they could
Mm-hmm.
actually set the weights, or if that is not possible, we could actually use we could actually calculate the weights based on based on the customer's preferences. So what do
Mm-hmm.
they want to prioritize? But in this manner, the criteria are actually based on the decision makers preferences, or decision makers criteria.
Mm-hmm. Mm-hmm.
So they establish these weights.
Okay.
But
So,
actually,
mhm.
I am the one who actually calculated this one because
Okay. So it means for simple, let's say, if you want to assign all the weeks equally, that's also possible for this approach.
yes, yes, oh, yes, you could
Okay.
actually have
Mm-hmm.
this 1/6 as weights.
Okay.
Okay.
So for this case, it means that criteria 3 will be have the most weight or
Yes.
considered the most important. And then after that, criteria 2,
Yes.
and then criteria 1, criteria 2,
Mhm.
and then 6, and so on, something like that, right?
Yes. But
Okay. Yep.
yes, Kay.
Yeah, okay, you can ask.
I have a question.
Mhm.
Mm-hmm.
I think this is more for Sir Mira.
Yeah.
How can you like make a criteria weight? Like how can you like
Mm-hmm.
mathematically like produce a criteria weight, sir?
Mm-hmm.
Because sometimes it's like preferential, like you just gonna be, oh, this is more important or something. But when it
Mm-hmm.
comes to like actually like providing values, because for
Mm-hmm.
the goal programming, it's like priorities. But
Mm-hmm.
for weights, like you assign weights to it and it's an actual value.
Yep.
So if everything is equally
Mm-hmm.
weighted, it's easy. You're just gonna be doing 1/6. But if have you need to find which one
Mm-hmm.
weights more. Is there any like mathematical method for that?
Oh, okay. Well, actually, yeah. So this is something that subjective, right?
Mhm.
Then assessing those as some kind of a procedural way, and then deriving it into a mathematical formulations. There is some approach like of pairwise comparisons that has been done and explained previously, like in the AHP. For example, okay, you have 6 week, and then you conduct pairwise comparison. Yeah,
Mhm.
pairwise comparison, right? There is
Yes.
the step by step of it, and then you will come up with this week. Remember when Red explained last week? I remember there is 3 criteria. You can compare 1 and 2, 1 and 3, and then 2 and 3. And then based on those weighted comparisons, then you can calculate, and then you got this weight. That is one way to approach it. And then if those criteria have somewhat how to say easier measurement to compare one to another, I think there is a way in the book of AHP, uh, in the later chapter, they include an an approach that you can compare the weight of each criteria. You can got the weight of each criteria using, if I'm not mistaken, rating methods. I think I can send you the book and then highlight the particular chapter for it. So basically, there is a way to do it, but normally in some methods like this one, ELECTRE, and then later on when you explain Topsiske, you will also find out that, oh, the weight is given, something like that, or the weight you can calculate any other way that you feel it's suitable, something like that. Okay. So I hope that one, regarding the mathematical formulation so far that we study about AHP, pairwise comparison is one of the way, but there is another way out there, something like that.
Okay po, sir. Thank you, sir.
Okay. Yep. Anything else?
Sir Red, do you have any question?
Okay.
No,
So
none.
yeah.
Thank you.
Okay.
So far clear pa naman.
Okay,
Thank you.
good discussion on the how to determine weight. Thank you, Williams. I think you can continue the explanation.
Okay. So now we have calculated the weighted
Mhm.
normalized matrix. We would now try to get the concordance sets. Okay. So
Oh, okay.
concordance sets is actually represented in this manner. So it's much different than matrices. So this is one way of representing matrix in based on sets. Okay. So how can we calculate? So based on this equation, the concordance KL, K represents the stronger alternative or row, and L represents the weaker row or alternative. So concordance KL would equal to the column J, or this one. The criteria is that the elements KJ, Y KJ, this one would be greater than or equal to YLJ, or this second row, okay, or the weaker row. Okay, do you, sorry, do you understand? I'm having difficulties in explaining in English.
Yeah,
So
so far. Well, I just want to share, no, I saw the video in YouTube, 51-minute video, and I appreciate this because in that video she actually tends to move from the Excel to the PowerPoint and back to the Excel. So I appreciate this.
thank
So
you.
far, yeah, I can get it so far. I'll just ask
Okay.
question later on. Thank
Okay.
you.
Okay. Yeah, just to make sure again, William. So CS1, S2 for criteria 1, it means that the concordance of subcon 1 and subcon 2 related to are associated with the criteria 1.
Yes.
Since the value of the Y, wait, can you go up a little bit? I cannot see the Y of the subcon 1 criteria 1 is 0.103 is less than uh, 0.129.
9 1
Therefore, the value would be 0, something like
0.
that.
Yes. Yes.
Okay.
Yes. Okay.
So with CKLJ, J is what?
J represents the column. Okay, so this one.
Okay,
Okay.
okay. Um, yeah. So, but so the value is only 0 or 1?
Yes, it's a binary component.
Okay.
Okay.
Okay. Okay.
So this is actually an if function. So if we would
Mm-hmm.
try to
Mm-hmm.
apply the if function,
Yep.
we would try to obtain if the sub row 1.
Mm-hmm.
So actually, okay. So first we try to explain CKL. So CKL means it row K outranks row L. So meaning for instance, subcon 1 outranks subcon 2. So meaning subcon 1 is much stronger than the subcon 2. That is what we try to prove here. So we try to apply the if function and if we achieve this argument, then we would apply 1. We would apply a dummy code of 1, and if not, we would proceed to 0. So in this row, if we would try to apply it here to all of the elements of subcon 1 and subcon 2, only criteria 2 was able to generate a 1 value. Now, generating the concordance set, or the CS1, S2, we see that criteria 2 was the only one to achieve an outranking value, or the concordance value. Therefore, he is the only one who would proceed to the set of this concordance. Okay, so is it clear so far?
Yes.
Okay, so we will apply this one to all of the concordance. Okay, so it's just the same. We would just have to uh, apply it to different rows. So this one we would apply it to subcon 1 and subcon 3. Okay. Now, getting the discordance or the opposite of this set is actually uh, is actually is actually quite easy. You do not need to do this anymore. You just once you know what would be the included uh, element in that set, then the remaining would be the discordance set. Okay. So here, for instance, in concordance S1, S2, we only have 2. So this means that 1, 3, criteria 1, 3, 4, 5, 6 would be in the discordance set of S1 and S2. So apply it to all of this to all of the rows and to all of the discordance sets. Okay. So we try to compare all of the sets to all of the subcontractors in a pairwise fashion as well. So this is actually a pairwise process. So we try to compare a two alternatives. Now, we would get the concordance first, concordance interval matrix. So how would we get that? So first, we need to recall the weights of the each criteria. Now, given in the equation of getting the concordance interval matrix, we would obtain each element by the summation of the weights that are actually included in the concordance set. So this one. So this is the concordance set. So J this sign and CAB represents this means that the columns that are included in the concordance AB set. So this is the concordance. Yeah. So for instance, this one concordance S1 S2, in its set it includes column 2 or criteria 2. So meaning we would get the summation of its weights in based on column 2. So we would obtain this value. That is why in S1 and S2 concordance interval matrix, it is represented in 0.1652 because that is the only criteria that is included in the set. So let's go on to S1 and S3. So it says that it includes criteria 3 and 5. So we would just add the weight of criteria 3 and 5. So here it is. Okay. Then the sum of that would represent the interval matrix or the interval element of each concordance. So apply it also to all of the concordance elements. So S2 and S1. So here it is. So it includes the summation of all the weights of 1, 3, 4, 5, 6. So we would just add that. Okay.
Okay, I think Kay raised hand earlier. Anything you would like to ask?
I I was just I just want to ask like for clarification. So
Okay.
basically you just add the weights to
Yes.
that?
The weights only. We would
So the matrix is not based on criterias anymore. It's based on subcon one versus another subcon
yeah,
for
yes.
the columns and
Uh
rows.
so now that you see here that we have the same row and column. So we
Mm.
try in this section we try to compare now each
Alternative.
alternative.
Mm.
Okay? So how can we compare that alternative? So basically we need to compare them based on our given values, which is the weights, so that
Okay.
we could create the
Thank you.
concordance interval matrix. Okay. So in discordance matrix, in the discordance interval matrix, it would be different. Okay. So now, I would just continue the concordance, since we would need to calculate also the concordance index matrix. So this is the next step before we head on to the discordance part. Okay. So we try to calculate the concordance index matrix. So this is the legends. So M represents the number of alternatives or the number of rows of the matrix. Okay. And the C bar represents the concordance index. So concordance index is actually the measure it's actually the measure that we are aiming for. It means that if we achieve the concordance matrix, the concordance index, then we can say that that particular element is actually much stronger than the other alternative. So uh, for instance, sorry, we let's try to calculate this so that we would know how we would apply the C bar. Okay. So in order to calculate the C bar, we would need this formula or this equation. Now, in order to calculate the one encircled in red, we need to get the summation of the summation of a particular row and column. Okay. So I just copied this matrix to this one and try to get the summation of the columns and the rows. Okay. So this one would be the sum. Sorry, sum. Okay. So this one, the sum of all columns. There you go. So actually, even though what element what row or even if we use row or column, we would still get the same sum for each of them. Okay. So I used this one, the row. Okay. So now we have obtained this encircled. Okay. So this is the summation of uh a particular uh concordance based on a row in a element KL, or the row and column. Okay. So once we have obtained the sum, we would try to multiply it to 1 over m times m minus 1. So m, we now know that since four, we have four alternatives, we would calculate the m times m minus 1. So 4 times 4 minus 1, which is 3, with result to 12. Then we would try to divide this encircled in red to the over m times 1. Okay. So 6.16520 divided by 12 would result to uh 0.51377. So that would be our C bar. So C bar is our concordance index. So meaning this is the concordance index. Now that we obtained the concordance index, we would now compare the concordance interval to the uh, sorry to the this pairwise function. Okay, this pairwise function. So if the element CKL, or the element in the concordance interval matrix, is actually greater than the concordance index, this one, then we would value it as 1. And if not, we would value it at 0. So we try to apply an if function again, comparing this element to the index. So obtaining all of the uh, completing the matrix, we would obtain this concordance superiority matrix or the concordance index matrix. So this will be used later on once we have calculated the discordance index matrix. So now let's move on to the discordance part. So we need to calculate the discordance interval matrix. But in order to do that, we need to recall first the weighted normalized matrix and the discordance sets, because this would be much needed in calculating the discordance interval matrix. Is it clear so far?
Yes, William. Thank you.
Okay. So in order to calculate the discordance elements, interval elements, we need to use this equation. So basically, the discordance element of a particular row and column would be equal to the maximum value of the absolute value of elements of the weighted normalized matrix minus the compared weighted normalized matrix that are the columns that are included in a discordance set. Okay, so this is the meaning of this one. It is the columns that are included in a set of discordance KL. Clear so far?
Can you recall again which one is matrix YKL and
Okay.
YLG?
Okay, so this one. Okay. So this
Mhm.
is the represents the weighted normalized matrix.
Oh, yeah,
So
yeah.
the one that we have calculated, the
Mhm,
weighted normalized matrix, we would get the difference of
mhm,
the used in the discordance value. So for instance, if we try to compare, sorry, this is subcon 1 and subcon 2, we
mhm.
would get the difference of these two values.
Yeah.
Okay. Now
So,
then we need to get the absolute value because we do not need the negative value in our matrices. Okay.
oh, okay. Yeah, correct.
Now this one represents the columns that are or the criterias or columns that are actually included in the discordance KL. So for instance, this one, these are the values or the criterias that are included: 1, 3, 4, 5, 6. Then
Mhm,
now moving on, we
mhm.
we would now divide it to the maximum value of the absolute value of the difference of the compared alternatives. So for instance,
One,
S1 and
three,
S2.
1, 4. Oh, so it should be from all. Wait. What for all the J? It means the criteria, right?
For all columns, for all criteria. So we would divide this to all. So uh for instance, we would if this one, we would divide this to all of these criterias. So
Oh,
let me just
okay.
show you. Let me
Mhm.
just show you.
So
So
good. Okay.
first let's try to
Get the
we,
upper part. Yeah.
get this one first, the
Mm-hmm.
absolute value, the most inner part of the equation.
Mm-hmm.
So the absolute value, let's obtain it this way. So for
Mm-hmm.
instance, let's calculate the S1 and S2.
Mm-hmm.
So get the difference of the each element for each column, then
Mm-hmm.
apply it for all.
Mm-hmm.
Now, once we try to get the discordance interval elements, we
Mm-hmm.
would now get this one, the maximum.
Yeah.
So let me just delete this first. This one. Okay. So this represents the upper
Mm-hmm.
portion of the equation. So this one, the maximum of all of the absolute values included in the discordance set. So as we can see here in this section, Can you see my mouse,
Yep.
my
D
cursor?
M1, M2, 1,
Okay,
3,
so
4,
you
5,
see
6,
here
7.
that 1, 3, 4, 5, 6 criteria 1, 3, 4, 5, 6 is included in the set of the discordance. So meaning
Mm.
we would need to get the maximum value for this uh, um, set of values.
Yeah.
So by eyeing, we are actually looking at highest this one,
0.
the criteria one.
Yeah.
Okay.
Yes. And then
Now,
divided by, yeah.
so we would divide it through all to all of this. That
Okay.
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 Sorry, this one.
Yeah, yeah, yeah.
Oops. Okay. So we would divide it to all of the computed absolute values.
Okay.
Oops. Okay. There you go. That's why we obtained one. Okay.
Yes.
So we would try to apply it to all of the discordance. Okay. To all of the discordance. Same process. Same process. Doesn't need changing. Only the values. So if we would compare S1 and S3, then get the difference of the subcontractor 1 and subcontractor 3. That's the only thing that you would change in this formula. Nothing else. Okay.
Mm-mm.
Okay. So
Okay.
now that we have obtained this one, let me just highlight it first.
William,
Mm-hmm.
how do you do the max function again? For what is that again?
Sorry.
The max function.
How the formula?
What does that do again?
So you get actually the maximum value, the maximum absolute value. Okay. So why do we get the maximum? So since this is the discordance sets, or the discordance area, we try to eliminate uh, the highest the highest the weakest, sorry, the weakest alternative among all others. So how do we know if it is the weakest? Then it has the highest discordance interval. Do you understand? So if you have a much higher value than others, then meaning you are much weaker than the other alternatives. That is why we are getting the maximum, not the minimum. Do you understand? Do I
Uh,
answer your question, Kay?
my question refers to the number one, the one you highlighted in green.
Okay.
Like, how did you get the values of that?
Okay. Sorry.
Yeah.
So this one, using this formula. So the maximum of the weighted values being compared, the weighted normalized elements being compared. So for instance, if this is we are pertaining, then we would get the absolute value of the elements of S1 and S2. Okay, so that's why we get the difference in an absolute value form. Now, getting this value, we need to divide the obtained maximum value of the absolute value of all of the included values in the set of discordance S1 and S2. That is why, let me just remove this first. That is why we establish this one, since in the discordance subcon 1 and subcon 2, we the values only included in this area is the 1, 3, 4, 5, 6. So we try to get the maximum of these five values. Okay? We try to get the maximum of these five values, then divided by all of the obtained absolute values. So we highlighted all so that we could get the discordance interval element.
Okay, good.
Okay. So that is uh, uh, moving on to the concept. That is why we get the maximum value, because the maximum value represents the weakest uh, the weakest um, the weakest alternative among the all of the alternatives. Is it clear?
Yeah, I get it. Because it's the
Okay.
other way around. That's why the
Yes.
higher the value, the
Yes. Okay.
Okay.
So now that we have obtained this, the one highlighted in green, we would put it in an interval matrix. So how do we put it? So simply, if we have discordance set 1 is weaker than set 2, we would we would put it this way. So set 1 to set 2, then we would put the value of 1. Okay? Just follow this. So uh the rows represent the first element, the first element. This represents the row and this represents the column. Okay, so we obtain that and apply it to all of the elements to complete the matrix. Okay. Now that we have obtained the discordance interval matrix, we would obtain the same fashion on how we obtained the concordance superiority matrix or this concordance index matrix. Okay, so it's actually a similar formula but in discordance. Okay, so we try to get the sum for columns and rows, then you choose whether you want to get the sum of row or sum of column because it will still be the same. Then m m would still be 4 since there are still 4 alternatives. So uh, uh, we divide this value to 12 and we would get the discordance index. Ex- uh, Excuse me. So now we would move on to the pairwise function. This is the one that would change because now that we are dealing with discordance, we prioritize the values that are actually much, much uh, lower since the much lower values represents a much higher rank, meaning uh, meaning that if alternative uh, let's say S2 has a much lower value than S1, then we would need then this means that S2 is much stronger than S1. So that is why we use the less than or equal to value, unlike in the concordance value where we we use the greater than or equal to value. Is it clear? Is it clear to this point?
Yes, William.
Okay. So same formulation. We would just need to change the equalization. Okay. So we change this to an greater than instead of less than or equal to, because if we use this one, we would need to create another if argument to represent this one. Okay. So as now that we have obtained this one, we can now create the aggregate of the uh, concordance and discordance element. Okay. So basically, we try to multiply the element to the equalized elements in the discordance. So we try to multiply this one. So here is the logic behind why
William,
we yes.
can you sorry can you go up please again? I
Okay.
just
Okay.
want to see something. Yeah, there. So can we check the value for S4 against S3
S4 and
and
this
S3?
one. S2.
So what is can I
Okay.
can you remove the formula please?
Okay.
Okay. So 0.3779 is less than 0.71.
Sorry. Yes. Yes. Okay.
Yeah, okay. Yeah, I got it. Thank you.
So we just use the if function
Yeah.
because uh siguro we apply this because we have a much lesser, it's actually quite difficult, but in a sense uh in Electre, we, as I said earlier, we have a lot of alternatives to represent. So
Yeah.
in a manner, we try to apply if function if we have more than 4, or possibly if you have a large amount of alternatives. That
No,
is
no,
why I try to apply the
no, William, it's okay. I just got confused on the value because the values apparently are not in the middle of the column.
Oh, sorry,
Yeah,
sorry.
no,
Okay.
that confused me actually.
Okay, okay.
I thought 3-0 is, yeah. That's the only concern.
Mm. Okay, okay.
Thank you.
So moving on to this aggregate. So this is the logic behind the aggregate. Okay, so we try to calculate the concordance index. The concordance index. Then we try to compare whether this concordance index is actually uh, uh, sorry, this should be greater than. There you go. There you go. Greater than or equal to the concordance index. If it is greater than the concordance index, then we need to now look for the discordance index, whether the calculated interval would be much lesser than the discordance index. Now, if we apply if discordance index does not met this argument, then the hypothesis would be rejected, which would represent in zero. And if it is accepted, meaning if the concordance argument and the discordance argument are both achieved, then we would represent the aggregate as one. But in a simple manner, we would just need to multiply the values since it is represented in a binary matrices. So for instance, since we have performed this one here, we compare the we compare the obtained elements to the uh, calculated discordance index. We were able to obtain one. So meaning we are finished in the diamond section of the process. Now we would just need to know whether if they both achieve this argument. So for instance, in this case, the concordance, this represents the concordance index matrix, and this represents the discordance. Okay. This is not part of the video in the so I try to search how you would actually obtain this aggregate. Okay. So for instance, S1 and S2, we would now calculate it to the similar element to the discordance index matrix. So 0, since it represents that S1 does not outrank S2. So meaning it's a no. Okay. Then then also discordance matrix also says that does not sorry does not outrank S1 and S2. So it's also a no. So that's why it is represented in 0. It is rejected. We would only achieve one if they are both achieved. So it is the if the computed interval elements is greater than the concordance index, and the discordance elements is less than the computed discordance index, then we would just achieve we would name the aggregate one. So for instance, this one, so we multiply this one times 1, so it would represent 1. So, so I'm so sorry, I do not explain it clearly, but do you understand?
I think you're doing great. It's just like we
Yeah,
now
it's
combine, right?
yes,
Yes, I agree.
Concordance and then discordance.
yes.
Whenever
I
both
agree.
is one, then it will be the
Okay.
aggregate will be one.
Maybe
Is
I should represent it this way.
mm-hmm.
Concordance.
The simpler like explanation is that when you multiply both terms, if you get one,
Mm-hmm.
then it's good. If you get zero,
Yes, but I
it's either
try.
because you did
Uh,
get both
yeah.
one.
So
Yeah,
I'm trying to explain the logic behind this. So if this is
one.
yes,
Yeah,
if this is yes, and this is no, then rejected. Okay.
yeah.
Right, there you go. It's much clearer. So
Yeah.
no and no, rejected.
Rejected. No, yes.
No, yes, rejected.
Yeah. Yes,
You
yes,
only
accept.
get accepted if it's both one.
Yes, okay. That's the only way that it is accepted. Okay.
Yep. Yep.
That is why we could actually
Yes.
multiply since it is represented in a binary value.
Mhm.
So 1 represents yes and 0 represents no. Okay. So now we have obtained this aggregate. We could actually interpret this. We could actually interpret this result. So as we can see, S2 is represented in an aggregate in S1. So this means that option 2 or alternative 2 or subcontractor 2 is absolutely superior than subcontractor 1. Okay? So that's actually the basic interpretation of that aggregate. So we apply it to all of the one values here in the matrix. So here. Now, you may ask, so why is it called an outranking method? So actually, this is one way of interpreting the result, and this is the other one that you could actually rank each of the alternatives. So this is the one included in the video. So I would explain it further. So as we can, we need to get the net superiority and net inferiority value. So here, it is calculated in this manner. Okay. So basically, it just shows the sum, the difference between the sum of the columns, um, sum of the columns minus the sum of the rows. So for this one, for instance, this one, S1, we try to minus this one to the sum in the columns here. Okay. So we minus this one. So this represents the first term of this equation. Okay. And this one represents the column. So by just obtaining that, that would represent the net superiority value. And then we try to rank. Since this is a net superiority value, we would rank the highest or the most positive value as the highest or rank number one. That is why S4 is actually ranked number one when it comes to superiority. And that is what we try to get in ELECTRE. So now in net inferiority value, you also rank it based on the most positive value. So why is that? Since this is a net inferiority value, if you have the highest or the most positive, meaning you are the most inferior uh, among all of this alternative. So if you have the most negative value, this means that you are more superior than the other one. So that is why in this case, in net superiority, um, S4, S4 or the alternative subcontractor 4 actually ranks 1, and in net inferiority he actually ranks 4. Okay? That is why he is ranked 4 in net inferiority. In the video, they actually they actually wrongly interpreted these ranks because they rank it based on the most negative value, but it would mean that uh, if you represent it, it would mean that rank 4 would be the number one most, or the rank 1 most inferior among them. And if you would try and if you would it's actually represented in this manner in the video, in that same as well. So if you would compare this one and this one, so in 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 logic, in superiority, uh alternative 1 ranks 4. So meaning he is actually less superior. But when you go to the net inferior, he's also rank 4. So meaning they just cancel each other out. You do
Yeah,
not
doesn't make sense.
you do not you do not have created a rank for them. So I have seen that mistake in that video,
Mhm.
and I have found that the net inferiority value is that the most positive represents the most inferior. Okay, the most inferior. Oh, one, four. There you go. The most
2, 3.
inferior. Yeah. So I I suppose you watched that, Sir Red, diba? You can see
Yes.
that in the video.
Yeah.
So so it does not make sense. So that's why I change it in this manner. So actually that's all. So as you can see, it's actually quite complicated when you're dealing with Electre. But actually, um, when you are using the software, I have read the book. You actually be able to compute it in just few minutes because you just need to input the data. But in Excel, we need to actually perform it manually. But if you can actually create a much more beautiful model in the Excel, then you just need to also input the values, and all of that would be calculated automatically.
I
Okay.
have a question.
Yeah,
Yes.
since we doesn't have the access to the software yet, maybe this will be very very helpful for
Yes. So
everyone.
I will send this Excel
Okay,
in our group. Yes,
assignment is
Kay.
okay. Okay,
I
K
have
K, yeah.
two questions because I didn't watch the video.
Okay, okay.
So, first question is that so which alternative is the best? Because the interpretation based on the first one you used on uh the green ones above, the option
Mhm.
three is absolutely superior or something.
Okay.
So it seems like in that the best alternative is going to be option two because it says that twice it is absolutely superior than two alternatives. But for the last way that you used, you use like actual numbers
Okay.
and so it shows that uh subcontractor four is the best option. So how can I like interpret that properly?
Okay, okay. So, in it's actually two ways, two methods. I just showed you the two one, but as you can see here, it's actually it's much consistent. But in this manner, kasi, we actually parang it's a generalized form in a sense. It is a generalized form because you are representing it in a binary fashion. So you are representing it in one and zero. So eventually you would not get that which among them is the most superior, but you would know which would be the most inferior because the main point of the electre is actually to eliminate the weakest alternatives. Okay, the weakest alternatives. So in this manner, if we could see here, all of these alternatives are actually outranks S1. So meaning S1 is actually the weakest one. So we could eliminate this. Now, the question, how can we know which is much more superior? Since these values, the remaining three, is calculated in a binary and based on the comparison of the D bar, the concordance index matrix, if there is a small difference, the index matrix tends to turn into zero. So for instance, this one S2 and S4, since it is much closer to the concordance index. Okay, since it is much closer to the concordance index, then we would result to a zero value. Okay, but if it's much more evident, then it would represent it in one. So now the ranking of alternatives is much more, in a sense, clearer. It's much more clearer since we would know which
It's more
alternatives.
reliable
Ah,
basically.
okay. Because it is represented on the computed matrices, not in a binary fashion. But in essence, you could actually use uh these two methods. This is just an aggregate in a binary fashion. Mhm.
But the binary is less reliable in that sense.
Yes, in that sense. Because this follows the more
Actual value.
actual value. Okay.
Okay. And last question regarding the ranking that you did,
Mm-hmm.
based that you changed based on the video. I just have an insight to that that
Mm-hmm.
might make the one in the video more sense because as you've interpreted, you said that, for example, the net superiority value,
Mm-hmm.
the higher the number, the better the rank. So basically
Superior.
0.9192 has the highest value, so it
So it
is rank
means the
one.
most superior. Yes.
So you're so basically that's as is. But for the net inferiority, you change the numbering the other way around. But I think the reason why in the video it's the other way around, like just the same as the net superiority values, because it it's just based on the net inferiority value. So basically, it's saying that the lesser my net inferiority value, the higher my ranking. I think that's why they followed the same. That's why the ranking is the same because the least one is S4 because it's negative 1.84. So it is the least inferior. Therefore, it is the best rank. You get
Some
what I
form
mean?
of consistency check.
Mm-hmm.
Yeah, some form of consistency because it makes sense. It's not that it cancel each other.
Mm-hmm.
It's just that it's less inferior, so I rank one. So basically if I say that uh I am, for example, I have like lesser mistakes, I am ranked one because I do less mistakes. Like my negative values are lesser than the other. So I'm the best
Mm.
alternative there is. I think
Okay.
that's why the
Yes.
ranking, the
Mm.
numbering in the video is the same as the net superiority value. It's not because of the value, it's because of the logic within the value. I think it's
Okay.
just an insight for me.
Yes, but uh if you would try to compare it based on the concept, we would much more understand why is it ranked in this manner. Because if you would represent this one as a high is as a much higher value, this would mean that it is much more inferior. Okay. That is why I ranked it as one, because we are obtaining the rank of which one is the most inferior one. If we would represent it in that sense, we would just have a consistency check. Okay.
Can
But
can we see the result and go back to or their original value of what is their
okay.
C1, C2 so that we can make sense of the
But this
result?
is the same value, but they just represented in the
Then
ranking.
I mean like let's say S1, what is the value for their criteria 1, 2, 3, 4, 5, 6? And then let's compare it with S4, for example, so that we can clearly see why this called superior, why the other one called the most inferior, something like that, William.
So this one,
No, no, no. You have this superiority value and then inferiority value already,
yes.
right? Let's
Yes.
go back to the original data. Go to
Oh,
the
okay.
top.
Oh, okay.
Yep. Nah, this one. So S1 would be the most inferior, is
Yes.
it? And then
Yes.
S4 is the most superior.
Mm-hmm.
Now, if you compare both, let's see. For the criteria one, we want the higher the better, right?
Mm-hmm.
So if you compare S1, S4 and S1, seems like S4 is higher than S1,
Mm-hmm.
right?
Mm-hmm.
And then about the C2, the higher the better also. So this one is equals.
Mm-hmm.
That's okay. because maybe the wakes cause it like
Yes,
that or
the weights.
something. Yeah. And then C3, what is C3? KPI, right?
Mm-hmm.
So this one also higher the better. Okay. And then what about the C4? Okay.
It represents the what's that? The sorry. The efficiency score. Sorry.
Okay. Sub 4 also higher than sub 1. This one, the efficiency is the higher the better or the smaller the
The
better?
higher, the better.
Okay. And then C5. Yep. And then C6. I think it's all checked about
Mhm.
those statement about inferior and superior.
Mm-hmm.
Okay.
Okay. Do you have a question as well? Again.
No, it's all good. I think the ranking, it's just an insight. I think that's why
Okay.
they followed it. So
Mm-hmm.
basically, you just went consistent with ranking it based on
Mm-hmm.
inferiority. But when you rank it based on which is a good alternative, it's gonna be the other way around.
Yes.
Because
Okay.
okay, yeah, that's what I was just saying.
Okay.
I
Okay.
think they just went straight to that, like ranking it based on which is a good alternative based on its inferiority value than ranking it actually solely based on the inferiority
Oh, okay.
value.
I understand. I understand.
Yeah,
Yeah. It's much more
yeah, they
clearer, but I try to put the logic behind, because if you would try to set the inferior, the word inferior itself, you would rank the most inferior one as one.
Mhm.
Okay. So I did not perform the consistency check. Okay. So that's my
So,
mistake. Okay.
yeah, so basically, as long as with what you showed, in the inferiority, it
Mhm.
is the like the best rank. It should be the worst rank in terms of inferiority.
Yes. Yes.
Is it that way? Okay,
Okay.
okay. Everything clear. It's a good presentation.
Sir Red, do you have any question?
Oh, it's very clear. A lot clearer
Mhm.
now than.
I'm sorry that I confuse
No,
you with this
no,
one.
no.
No,
It's
it's
clear.
all good.
I understand. I understand the way you explained it.
Okay.
Thank
Thank you
you.
very much.
Yeah, I think you're doing great, William. So, yeah, this method somewhat it doesn't really, yeah, we can use this method to somewhat not really having much involvement on with the expert,
Mhm.
because let's say as long as the value at the beginning is well set,
Mhm.
and then we can do the follow the procedure,
Mhm.
and then we got all those
Yeah.
results at the end of
Yes.
it. If we compare to the AHP approach, perhaps the expert need to do a lot of comparisons. Let's say if this one they have 4 alternative, they need to compare it 16 times. And
Yes.
then when they have 6 criteria, so they need to compare it 36 times,
Mhm.
right?
Yes.
Yeah, so I think there is a benefit of it, but yeah, it depends again. Like
It's like at what cost? Because as you can
mhm,
see, it involves a lot of computation. It involves
computation,
binary matrices, sets, then pairwise functions.
exactly.
Yeah. Unlike in
Uh,
AHP, you just use pairwise.
yes, yes, right.
I just want to add that compared to AHP,
Mm-hmm.
this electric actually is very similar if we use AHP using the direct method, meaning you're putting in the actual
Yeah,
values,
yeah,
the
Yes. Yes.
questionnaire type.
Yes.
direct method,
Yes.
exactly. And there is a rating system in AHP.
Mm-hmm.
Last time, Red, you explained until chapter 5 of the book. If you continue chapter 6, there is something called rating system. This will
Mm,
be quite similar with this one.
okay.
But the main difference with this, Sir
Mm-hmm.
Red, is that once, unlike in AHP, as I said earlier, the the outputs generated by AHP is based on the priorities set
Yeah.
in the criteria. So if once we change the set of priorities, the alternatives could possibly change. But
Mhm.
in Electre, we compensate that process so that we could get the much more weaker and much more stronger alternatives without setting priorities to all of the criterias. Yes.
Yes, I agree. Thank you.
Yeah. Thank you for
Okay.
that insight, Sir Red.
Okay, I'll stop the recording first. Thank you, William. So again,